this project, JWST, it's the next huge step in furthering our understanding about the universe. It's almost like there's a curtain beyond which we can't see. And the big picture of how did it all come to.
For thousands of years, people thought the Earth was in the center of the universe and everything revolved around us. 200 billion stars, so big it takes light 100,000 years to cross it. 13.8 billion years ago. This was the beginning of time and space, of gravity. Tendrils of material began to coalesce and the first stars and galaxies shone forth.
Luminous objects to occur, the first stars, the first galaxies, the first black holes, whatever it was. So our idea, one of our most challenging projects for this new telescope.
Most earliest galaxy in the universe.
Difficult, that one would say it may not be possible.
The telescope was originally set to go to space as early as 2011.
So it's that constant thought, did we think of this? Did we think of that? Did we think of this? Because the slightest thing that could go wrong.
Until very recently, the only planets we knew existed were the ones in our own solar system. But then, exoplanets, planets around other stars were discovered. Thousands of them. And a new generation of astronomers realized they could use the telescope to study them.
There was no other question worth answering. We're hoping that JWST is successful so that we can actually get some really astounding observations of these planets.
For the 6,000-mile journey through the Panama Canal to the launch pad in French Guiana, it had cost $10 billion. And NASA and its partners, the Canadian and European space agencies, were counting on it. Failure would be.
Good morning and Merry Christmas from the Guiana Space Center in Kourou, French Guiana.
It's a laser focus here in the control center as we get closer to launch.
I watched the launch.
Make web possible. They're ready to go, and I'm ready to go. There's always a feeling of holding your breath at launch. The butterflies are strong once we see far from the ground.
So launch is shock. Now you're lit, right? In this explosion, right? That has to get you in orbit.
It's the most violent environment you can shake and stuff like that.
Institute, their work just beginning.
About 45 seconds into that video, you see this thing deploy, this accordion panel.
A bit earlier than planned, but there is the solar array.
And we were never supposed to see that.
And there it is. There's your critical call. The telescope not only has legs, but it has power.
It was waving goodbye.
This will be humanity's last view of the telescope as it moves to its workplace about 1 million miles away from Earth.
Now comes the riskiest part of the mission. Over the next month, the telescope must fly to a location called L2, 4 times farther than the moon. On the way, there are
A lot. And we have 344.
Okay, just want to confirm you see first motion.
I can confirm first motion.
Copy, just give us status as we move on down through the movement.
OCP, your go to fire.
Wickrams go. All stations, this is Mom on Ops. We're a go at this time to finish Sunfield tensioning.
Every hinge that has to move, every cable that is going to deploy a sun shield that's going to pull it out, 90 of those single point failures. If one of those didn't work, it literally could have been the end of the mission, and we just could have floated out into space as space junk.
This time.
With the concur.
And we have a fully deployed JWS geoserver.
My mom's coming out to look for me, and I didn't answer her, and I was laying on my back looking at the stars.
Away in its cold orbit out at L2. The telescope now turns its golden eye to a tiny sliver of the sky, no bigger than a grain of sand held at arm's length. It's looking past the stars in our own galaxy into the emptiness of intergalactic space. It stares for 6 hours, the detectors collecting light from the distant universe. What it sees is beamed back to Earth in a series of ones and zeros over the deep space network.
Good morning, everyone. For 2 decades, the reveal of the first science images from the James Webb Space Telescope.
Okay, we've got the whole world watching. Are you ready to put the first image up? Oh, let's do it.
When the telescope stared at that dark sliver of the sky, it saw this.
So the first image is a deep field.
Except for a few spiky stars, these are all galaxies. They're all sizes and ages and colors. The deep field was designed to be a test of the telescope, and it was working better than anyone imagined.
All those dots that you're seeing are not stars. The majority of them are galaxies. Cities, each one with about 100 billion to 300 billion stars on its own.
The brightest galaxies are part of a cluster 4 billion light years away. The light we see from them took 4 billion years to reach us. It left those galaxies around the time our solar system and the Earth itself was forming. But these aren't the farthest things we can see in this picture. Far from it.
The other thing that's extremely incredible is that the universe is providing us an even bigger telescope.
Little arcs, strange-looking little arcs, curved things that don't look like anybody else's galaxy at all.
What you're actually seeing is the effect of curved space. Space like between you and me, where the geometry doesn't behave itself.
This is called a gravitational lens. Einstein said it should happen. He thought we'd never be able to use it for anything, but he knew it could exist.
A telescope is a time machine, and JWST is the most powerful one ever built. It can see deeper into the past than any telescope in history, revealing a hidden part of the universe. Galaxies glowing in infrared light from soon after the Big Bang.
There's a bunch of little red rubies all throughout the image. Oh, there's one. Okay, yep, they're here. Yes, this is going to work.
This picture is just a few pixels across. The images emerging from the darkness reveal a whole new universe. An infrared universe. Invisible to the human eye. This group of galaxies is called Stephan's Quintet. They look calm enough at first glance, merging as they're torn apart. Tails of gas and dust whip through space in torrents of fire. Looking farther into the infrared reveals something very strange. Glowing at the center of one of the galaxies is an enormous black hole. It's 24 million times the mass of our sun, and it creates a dent in space where gas and dust tumble in. The material circles faster and faster, emitting energy and light before disappearing into the darkness. Phantom galaxy. But JWST reveals its skeleton, the clumps of gas and dust where a new generation of stars is forming. In the Tarantula Nebula, the telescope sees stars actually being born. They're still shrouded in the dust of cosmic birth, but infrared light goes through the dust, taking us into the stellar nursery for the first time. The landscape on Earth. But really, it's a vast cloud of gas and dust being blown into this shape by the bright stars above it. They're young stars that have recently been born. The cosmic cliffs are in our own galaxy, only 7,600 light years away, nearby compared to the distant universe.
Something that we couldn't see before. I once was blind, but now I see.
The telescope has shown us how stars are born, and it also shows us how they die. When the fuel in the core of a star starts to run out, it becomes unstable. The star at the center of the Southern Ring Nebula is blowing off gas and dust in an enormous bubble that expands at thousands of miles an hour. And JWST found this star on the brink of a more dramatic end. It will soon go supernova, exploding in a fireball that can outshine the entire galaxy. This is the remnant of a supernova that could be seen in 1667, not long after the time of Galileo. The star is now gone, but its material has been blown into interstellar space.
Multiple generations of stars exploding and casting that matter out into space. And then that matter gets sucked up into the next generation of a gas cloud that's collapsing and forming a new star.
You know, you look up at the night sky and everything seems so distant and far away, but that's our origins. That's where we came from.
New stars are being born in our galaxy. It's called the Pillars of Creation. The Hubble telescope took this picture in 1995, but it couldn't see through the dust. JWST sees right through it. The stars are formed when the gas collapses under the force of gravity, compressing into spheres that get hotter until nuclear fires ignite in their cores.
Star formation is how we get the heavier elements. Atoms are literally crushing together to form the oxygen that we breathe, and the iron that's in our blood, and the calcium in our bones. It all came from a star.
We are made of stardust. The nuclear fires in the cores of stars and supernovas make the heavier elements. These elements become clouds of dust in the spiral arms of galaxies, forming out of interstellar clouds of gas and dust. In the center is a line of material that spins as the star is born. Past giants like Jupiter, and some will be rocky like Earth. This is how our solar system formed 4.5 billion years ago. The telescope now turns to our own backyard, revealing new details about our planetary neighbors. the rings of frozen Neptune glowing in infrared light. Uranus, the only planet in our solar system, tilted 90 degrees on its side. Astronomers think this may be from a collision with another object in the distant past. Saturn, with its famous rings and a few of its 146 moons. Astronomers hope to find more, maybe even in this image. Jupiter, shrouded in clouds of frozen ammonia and methane, and its moons that Galileo saw 400 years ago. And then there are the asteroids.
Control system settling down, angular rates look really good.
The protoplanetary disk left behind millions of rocks circling the sun. By studying the explosion, the telescope and observatories around the world found that the path of Dimorphos had been altered. Now we know that if an asteroid is headed our way, we might be able to do something about it. The Earth is an oasis in a vast universe. In spite of all we've seen, it's still the only place we know there is life. The atmosphere of our world, with its delicate mix of oxygen and carbon dioxide, and its surface of water and rock, has made life possible. Could there be another living planet out there?
Are there any other planets like ours out there? Is there water, liquid water on the surface of another planet? Because that would be the first signpost of life.
JWST now turns to gaze at a star 1,300 light years away. Orbiting around it is a planet called WASP-17b. A team of exoplanet astronomers is finally getting some data back to water vapor in the atmosphere of WASP-17b. But this is no place for a vacation. It's known as a hot Jupiter. It's so close to its star that the planet is 1,700 degrees and the water is scalding steam. The team also identified quartz crystals and sulfur dioxide enveloping the planet in a thick fog. We won't find life on WASP-17b, but it's a star system called TRAPPIST-1 with 7 Earth-sized planets around it. Unlike WASP-17b, the TRAPPIST planets are not made of gas. They are rocky, like the Earth. The planets closest to the star will likely be too hot to keep an atmosphere. And the farthest ones will be frozen solid. But there are 3 planets in the middle where liquid water could exist.
TRAPPIST-1 might be the best system that we will uncover in terms of being multi-planet, in terms of having all the vacation spots you can think of. Very cold planets, very hot planets. TRAPPIST-1 is pretty unique.
Pushing the telescope to its limits, the team is trying to detect an atmosphere around TRAPPIST-1e. An atmosphere hasn't been found on a rocky exoplanet yet, and it would be a big leap forward in the search for life.
The universe is so big, you know? I think there's no question that
has transformed the night. We're close to seeing the beginning of time and space. We are close to seeing first light. We know there are as many as 1 trillion galaxies, each with hundreds of billions of stars and more planets than grains of sand on all the beaches of the world. We've always been a lonely species, floating in space, wondering, hoping, wishing, longing.